I wanted to talk a little bit about the Tasty Fruit assignment that everybody did. And I think everybody got the general idea, but I wanted to point out that this can be made more mathematical if you want to. Everybody talked about the axes for the horizontal axis being ease of eating and more difficult eating if you have to peel the object or cut up the pineapple or whatever, and the y-axis being how tasty it is. But you can actually quantify that, and maybe you could take surveys or something to find out that people tend to think that a scale from -6 to 6 for how easy or difficult the fruit is to eat, 6 to -6 for how tasty it is. And so maybe peaches would be, you could give them an XY coordinate, and peaches would be 3, 5, which means they're 3 on the easy list and 5 on the tasty list. Seedless grapes would be 5, 4 as their coordinates. And you could give every fruit a coordinate based on the two parameters. And so in this case, you can talk more easily about some of the questions that were asked. If you wanted to know if green apples were, how different green apples were from red apples, well, that you could look at their tasty value, their Y value. And on the Y-axis, green apples are at 1 and red apples are at -1. So green apples have a higher taste value. And you can talk about looking at a fruit on the Y-axis, looking at its Y coordinate to determine how tasty it is or compare it to others. If you wanted to know what are some things that people thought were had equal taste value and equal ease value, that would mean when, for instance, y equals x, the taste value equals the ease value. And that would be like a line, the y equals x line. So, for instance, cherries would be 2, 2. They're pretty easy and they're pretty tasty, the same. Or grapefruit down here is really difficult and really untasty. And in that sense, they're equally untasty, have the equal taste value as ease value. And you can describe these things in a graphing sense. That's on the diagonal line, right? What about, one of the questions was, which does the author have the strongest opinion about? And a lot of you talked about it being far away on one of the axes. So for instance, pineapples were very difficult. And so there was a strong opinion about pineapples being very difficult to eat. But you could think about this mathematically and say the opinion that the author had about something was either very strong, either very easy or very difficult, or very strong opinion, either very tasty or very untasty. And so that tends to an idea of far away from the center of this chart. And so you could mathematically, or you can make that a mathematical thing by saying that maybe the strength of your opinion, it could be a function down here. The strength based on its coordinates x, y is the distance from the origin, square root of x squared plus y squared. And so all of these things on the purple circle would be about the same strength of opinion. So the author really, really likes peaches, both for ease and taste, and they really, really don't like grapefruit, both for difficult and untasty. So, but that's also another thing, you could make a mathematical formula to quantify these things. One other example that I had was people were asked to describe which was the best or worst fruit. And a lot of you said, well, peaches are the best fruit because they're highest, or lemons are the worst fruit because they're lowest on the y-axis. But that's just in terms of taste. What if you worried about whether they were best or worst in terms of ease? Then it might be seedless grapes are the best because they're easiest, pineapple's the worst because it's hardest. But really, best and worst might be some combination of the two. So maybe you could come up with a formula for the desirability. And maybe that would be that it's easy, how easy it is and how tasty it is, the combination of those. And in that case, what's nice is you get a line like these two. Let's say this, x plus y equals 9. These red and orange lines that I've drawn are kind of the all of the points that are at a desirability level of 9. These in the middle here are all the points that are at a desirability level of 4. And so cherries and red apples are the same desirable. Apples aren't as tasty, but are easy to eat. Cherries are a little bit better tasting, but are more difficult. But overall, in the combination of those two things, those are equal. And so you can actually set up a mathematical equation to then figure out which one is the maximum. As you want to raise this this desirability from the lower left line to the upper right line, and the value of the desirability gets larger. That's actually a function you can describe. It has 2 input variables, x and y. Or maybe you want to make one where the emphasis is on the taste. And so you can put a weight on the taste variable, make it worth 3 times as much as the ease variable, and then you get a line. You get a different line. Maybe your line is where is the desirability kind of balance out in the middle. That's going to be when x plus 3y equals 0. So that's going to be things like bananas and watermelons and pineapples. In this case, they taste pretty good. They're really difficult to eat, but their taste balances that out, and so they're kind of in the middle. In this case, that would make peaches have a desirability of 18, and grapes have a desirability of only 17. But again, you can get these lines where the d of xy, the desirability based on the combination of x and y, is at a certain level, and you want to increase that or decrease that. So in this case, as an example, grapefruit is now worse, quote unquote, than lemons, because it's just a little bit better tasting, but it's a lot more work. It's a lot more difficult. And so in that combination, in this case, grapefruit is worse, quote unquote, less desirable than the lemons. So I wanted to point out that you can make even a silly example like this, you can make it mathematical types of equations to solve the types of questions we were asking in a more in a less mathematical way on the chart. So I think that's interesting, and I want you to keep these things in mind as we go.